Hello friends, welcome to Coding Host YouTube channel. In this video, I will explain a program Tower of Hanoi. So in this program, we have three towers, 1, 2 and 3. So initially, we have these three rings in the tower 1. So we have to move these rings to the tower 2 with the help of tower 3 because at a time we can only remove one ring from this tower and we can only place small rings above the larger rings and we cannot place any larger rings above the small rings. So this is the rule. So you can see that this ring blue is small and this ring orange is larger. So we can place this blue ring on the top of the orange ring, but we cannot do opposite. We cannot place orange ring on the top of the blue ring. So this is the rule. So we only have to write the instruction that how we are going to move these rings one by one in which tower. So in the end all these ring will get set in this tower 2. So we only have to print the instruction. So let's write the program. So in the program, first I will make a method public static, and in this question we do not have to return anything in the main method. We only have to print the instructions. So I will use the return type as void. Then the method name is Tower of Hanoi, so TOH. So I will make the body of this method later. First I will call this method here inside the main method, so Tower of Hanoi, and here we have to pass all these four values. So first is number of rings, then tower 1, then tower 2 and tower 3. So we have entered all these arguments in the method. So now I will make these parameters here. So int nor, then int tower 1, then int tower 2 and int tower 3. First I will call this method again. So Tower of Hanoi, and inside this first we have to pass number of rings, then tower 1 will remain as it is, but we will swap tower 2 with tower 3. Then we are passing here tower 3 and then we are passing tower 2. So this is our left call. Then we have to print here the instruction. So system.out.println. So first we have to print ring number, so nor. Then we have to print t1. So we have to print this arrow symbol here. So it will show that this ring is moving from this tower 1 to the next tower, which is tower 2. Then we have to call this method again. So Tower of Hanoi, number of rings, and now we have to swap the first tower with the last tower. So here we will pass tower 3, then tower 2 will remain as it is and tower 1. So this is our right call. So in this method we have to call this method two times, left call and right call. And one more thing, we also have to decrease the number of rings. Here is also same, and we also have to write a base case here. So what is the base case? You can see that in every method call we are decreasing this number of ring. So if number of ring equal to 0, so that time we have to return. So let's run this program. So you can see this program is working fine. Our instructions are getting printed. So now let's see how this program is working. So you can see that we have these four variables, number of rings which is 3, then the tower 1 which is 1, tower 2 is 2 and tower 3 is 3. So we are passing all these values in this method. So now you can see that in this method we are calling this method two times. So that time we cannot explain the working of that recursive function using the stack memory diagrams. So I will use here a different type of approach to explain you the working of this program. So I will use here tree diagram. So when we are calling this method here for the first time, so number of rings is 3, then tower 1 is 1, then tower 2 is 2 and tower 3 is 3. So from here we will make two branches. So this is our left call and this is our right call. So you can see that we are decrementing the ring. So now this ring will become here 2. So after that what we are doing, tower 1 will remain as it is. So here 1 will remain as it is, but after that we are swapping tower 3 and tower 2. So here tower 3 will come in the place of tower 2 and tower 2 will come in the place of tower 3. So this is our left call, and what we are doing in the right call. So here a number of rings will also decrement, so it will become 2. Now you can see that here we are swapping the first and the last tower. So then this tower number 3 will come in the place of tower 1 and tower number 2 will remain as it is. Then we have tower number 1. So you can see that first we are calling this method from the main method. Now this method is calling itself two times, left call and right call. So from here, now this method will call itself 2 times also. So here we also have this left call and right call, and same will happen for here. So here what will happen in the left call, you can see a number of ring will decrement. Yes, it will remain 1. Then you can see last 2 tower will get swapped. So we have to swap tower from here. Now we don't have to see this initial towers, we have to see these towers from here. So tower 1 will remain as it is. Now this second and third towers will swap, so it will become 2 and 3. Now here in the right call, you can see that a number of ring will also decrement, so it will become here 1. So you can see that when we are doing the right call, only the first and the last tower will swap, the middle tower remain as it is. So here you can see that 1 and 2 tower will swap. So here we will get 2, and in the center this 3 will remain as it is, and then we will have tower 1. Now we are here in this method. So for this method also we have to do the left call and right call. I am writing here, this is the left call, this is the right call, then this is the left call, right call, then left call and right call. So now you can see number of rings will decrement, so it will become 1. Now when we are doing the left call, we only have to swap the last 2 towers. So this 3 will remain as it is, then 2 and 1 will swap. So here we will get 1, then here we will get 2. Then in the right call, we know that first and last tower will only swap. So here also number of rings will decrement, it will become 1, and this 3 and 1 tower will swap. So we will get here 1, then in the center we will have tower 2, and then we will have tower 3. Now you can see here, after this also we have to do the left and right calls. So you can see when we will do here the left and right calls, what will happen, number of rings will become 0. So we don't have to do anything, we only have to write here 0, because for number of rings equal to 0, we only have to return. So here this is the left call, which is also 0, and right call will also 0 for this next iteration, and here also we will have 0 and 0, and here also we will have 0 and 0, and here also. So now this program will stop here, but how it will print the output? So you can see that when we are going upside in the recursion, we call it as pre-call. So when we are going in the pre-call, nothing will happen, we are only going up. Then after that we are going down, so it is known as post call. So first we have pre-call, then we have post call. So in this we will go upside, and in this post call we will go downside. But between these 2 type of calls, we also have one more call, which is known as in call. So you can see here we are going up, but after that we are going downside, but between here this is our in call. So you can see I have written here this println statement between this left call and right call. So this println statement is for the in call, for printing the instruction. So you can see that when we are going from here upside, nothing going to happen, but when we are going here downside, so we will reach here in the in call. So that time what will happen, we have to print this instruction. So you can see that we are only printing tower 1 and tower 2. So here I will use a different color. So now I will show you what will going to happen. So you can see that in the starting we are going upside. So when we will reach here in the middle of this calls, that time we are printing the instruction. So in the instruction what we are printing, first is the number of rings. So number of rings is 1, then we only have to print tower 1 and tower 2. So then we are printing like this, tower 1, and then it is arrow symbol and tower 2. So this is our first instruction. Then from here we are going upside, but after upside you can see we have this 0 here, and when we have 0 we are returning back. So from here we will go like this, and then we will reach here. So here we also have to print the instruction, because now we are in the in call. So you can see that first we will print the number of ring, which is 2, then we have to print tower 1 and tower 2. So here tower 1 is 1, but tower 2 is 3, so it will print this instruction like this 1, and it will going to 3. Next from here you can see again we will go upside, then it will go back from here downside, because here is the return statement. So now here we are again in the in call, and it will again print the instruction. So you can see here number of ring is 1, then number of tower 1 is 2, and number of tower 2 is 3. It will print it like this. Then from here it will go here down, so you can see that it will go down like this here, and then it will reach at this instruction. So here also we are now in the in call, so it will again print the instruction. So it will print number of rings. So number of ring is 3, then tower 1 and tower 2. So 1 and this arrow symbol, then tower 2, then we are again going upside. So when we will reach here at 0, then we will go back. So now we are here at this instruction, so again we have to print the instruction. So then number of ring is 1, then tower number 1 is 3, and tower number 2 is 1. After that from here we are going here to the right call, but after that we are going down. So now we have to print this instruction. So here number of ring is 2, then tower 1 is 3 and tower 2 is 2, and after that from here we will again going upside to the left call, but then we are going down because here is a written statement. So now we are printing this instruction. So here number of ring is 1, then tower 1 is 1, but tower 2 is also 2, and from here you can see we are going up, but then we are going down here. So you can see that. So this is how this flow is going. So you can see that first we are printed this instruction, then we have printed this instruction, then this instruction, after that this middle instruction, with then this instruction, then this instruction, and in the last this instruction. So total how many instruction we have printed? 1 2 3 4 5 6 7, and here also 1 2 3 4 5 6 7. Now we will match this dry run output with the actual output of our program. So you can see that this dry run output is matching with the actual output of our program. But if you want to check that how this instruction is actually working or not, I will also show you a simple example. So this is the first instruction. We have to move the ring number 1 from tower 1 to tower 2. So this is the ring number 1. So we are moving this ring to tower 2. So we have executed first instruction. Then we will execute the second instruction. We have to move the second ring from tower 1 to the third tower. So this second ring will go here. Okay, so we have executed this second instruction also. Then we have to move this ring number 1 from tower 2 to third tower. So we are moving this ring to this tower here. Okay, so we have executed this instruction. Then this next instruction is we have to move the third ring from tower 1 to tower 2. So we are moving this ring from tower 1 to tower 2. So this instruction also executed. Then we are moving the ring 1 from third tower to first tower. So this ring 1 will go back here in the tower 1. So this instruction is also executed. Then next instruction is we are moving the ring number 2 from third tower to second tower. So we are moving it here to the second tower. So this instruction also executed. Then in the last we are moving the ring number 1 from tower 1 to tower 2. So it will go back here in the tower 2. So you can see these instructions are actually working fine. This is how we are writing the program for Tower of Hanoi using Recursion. Thanks for watching.